These mirrors are free, and I will describe how they are manufactured and how they are installed in a solar concentrator. These mirrors can be used for these various concentrators, parabolic trough. Mafre mirrors are made from these strips, which are scraps of large mirror sheets in a variety of glass workshops. In other words, these mirror strips are garbage, and they throw out these strips. Thus, we need to give these mirror strips the right length, and I do it with a glass cutter. The result of this works is these sets for mirrors with different widths, and I made these sets from this heap of mirror strips from one small glass workshop, and this heap was collected during 6 months. Now I am showing the manufacture of a mirror from one of those sets, and this is a sheet of expanded polystyrene with a thickness of 3 cm, and this is matches. We can see that the strips are put according to their widths, starting from the widest and ending with the narrowest. This is the tracks of polyurethane foam, and they are put with an interval of about 5 cm. Immediately thereafter, the strips are turned. After that, we put flat battens with loads on our mirror, and the surface of our table should also be flat as possible. Then we remove the load and this matches. In addition, we can remove those pieces of hardened foam, and I have a hypothesis that these pieces will interfere with the focusing of the mirror. If we want the number of these pieces of the foam to be as small as possible, we must put those foam cracks in the form of such zigzags. Now I show mirrors which has been operating during 8 or 9 years outdoors, in the cold, rain, snow, etc. We can see that the edging of the mirrors gave defects to their reflective layer, but these defects cover approximately 1% of the area of the mirrors. That is why I predict that the lifespan of these mirrors will be 15 or 20 years. However, the lifespan can be reduced by hail, but these mirrors have already survived hail with a diameter of up to 10 or 15 mm in 2013 and 2021. I think that the main cause of these defects is some substances which are in the polyurethane foam, and they gradually destroy the reflective layer. In addition, perhaps the cause of these defects is moisture, which is retained by those foam tracks. Now I will show how to install this mirror on concentrator, and this requires 6 points of polyurethane foam. You need to pay attention to this support of the mirror. This support is temporarily installed on the concentrator, and we can remove it in a few hours. We must pay attention that more narrow strips of the mirrors should be placed here, on the periphery of the concentrator, and wider strips should be here, closer to the center of the concentrator. We need to make the right width of the interval between the mirror and the concentrator, and these wedges are one of the possible methods. The upper edge of the mirror must also have the interval of the right width. Then we put the foam points at a depth of 20% of the height of the mirror. I want to clarify that now we do not see those wedges, and this video is an example of another method of ensuring the right width of the interval, and now it is done by small flat pieces of wood, which is not shown by this video, and we must remove those wooden pieces in a few hours. The upper part of the mirror also receives similar foam points. Now we give the right width to the lower interval. The upper interval must also have the right width. Then our polyurethane foam fixes the upper edge of the mirror and its lower edge, and it is obvious that we can remove these wedges in a few hours. However, we did all this when we already knew the right width of those intervals, and it is obvious that we must install our first mirrors in a different way, and I will describe it further, and one of our goals is to measure the right width of the intervals. The start of the installation is the same, and we put these 6 points of polyurethane foam. Then we put the mirror on the concentrator and wait 24 hours. Then we cover the bottom and the top of the mirror, and after that we use these wedges to choose the width of the interval so that the solar radiation spot has the lowest height. It is obvious that the width of the upper interval is chosen similarly. After that we measure the width of the upper and lower interval, put the foam at a depth of 20% of the height of the mirror and wait 24 hours. Then we cover only the upper part of the mirror and choose the optimal width of the bottom interval for the minimum height of the spot. Then the covering of the top of the mirror is removed and we change the width of the upper interval to reduce the height of the spot. Now we can see that the optimal width of the upper interval was chosen. Then the width of the upper and lower intervals are measured, and we fix the lower and upper edges of the mirror. Now we see the spot of solar radiation from our mirror, and the spot height is about 13 or 15 centimeters. But if we want a lower spot, we need to use some other technology for manufacturing and installing mirrors, which should be made of these narrower mirror strips. This is my result of sorting the mirror strips before making the mirrors, and I made my mirrors only from these strips with a width of more than 3 centimeters. But the production technology of this video cannot be used for these narrow strips, because such mirrors will have poor focusing. We can notice that I sorted these mirror strips according to their brands, which can be distinguished by the color of the paint on the back of the mirrors. This was done to satisfy the condition that the differences in the thickness of the glass of different strips of the same mirror should be less than 100 or 200 microns. In addition, I want to clarify that focal lengths of our mirrors should be more than 80 centimeters, and if we need a shorter focal length, our mirrors must be made by some other technology.